All right. Greetings, Earth and Space cadets. I'm Bill Waller, an astronomer and science communicator who for the past 10 years has been teaching physical, earth, and space sciences at Rockport High School in Massachusetts. Today, I would like to share with you this pilot program, what I'm calling Doc Waller's Earth and Space Report. So the first thing I need to do is share the screen, and I have that. I'm going to share it and go to my PowerPoint, which is now a PDF. And here we go, Doc Waller's Pilot Earth and Space Report for April 23, 2020. That's actually the day after Earth Day, but I had glitches, technical glitches I had to learn about on Earth Day, and so I'm presenting this today, one day late, maybe $1 short too. Okay, there's very good reason to celebrate the progress that has been made in improving our air and water quality, this being the 50th anniversary of Earth Day. But there is even more reason to redouble our efforts in the face of an ever-warming climate that has been brought on by our continued burning of fossil fuels and the resulting increases of greenhouse gases in our atmosphere. In this Earth and Space Report, there's plenty to consider on both regional and global scales. So let's begin with the weather local to Cape Ann and move on out to global atmospheric patterns, global coronavirus infections and their trends, earthquakes and volcanoes that have been happening recently, the sky at night during this spring season, and seasonal celestial objects. All right. So we're going to begin with the most local of all, and that would be our weather station here at Rockport Public Schools, which has been having basically a pretty steady northwesterly breeze. The gusts yesterday were around 20 miles an hour. Temperature was about the same. It's a little bit cold for this time of year, April 23rd. Should be around the 50s. We are currently in between two weather systems. One that went through on Tuesday and one that's coming on Friday, which would be tomorrow night, okay? And so it would be nice to show those weather systems, and I'm going to show them to you soon, but just I want to note that it's pretty much new moon. New moon actually occurred yesterday at sunset, around sunset, and that marks the beginning of the holy month of Ramadan for the Islamic faith. And so that will last for a full month to the next new moon. All right, so what do we want to see next? We want to see this loop of weather systems coming through. The daytime has come, and we can see this new weather system coming at us and will reach us here in Massachusetts on Friday. All right. We can go even further globally. We can look at what the Earth looks like as a globe. And there's a lot of weather. I believe we are now in the Pacific, looking at all sorts of weather systems, mostly in the Northern Hemisphere. And this is actual data. This is visible views of the cloud patterns across the Earth. But what I find easier to work with is a modeled set of data, and that would be with the Null School, which is located here. And things don't move around as much, and we can concentrate on what we're seeing. Locations, you can see that there is this counterclockwise flow. That's the result of the storm that passed by us. The storm front, I believe, is somewhere around here now, but we have activity coming at us from the west. It's often nice to see a different representation of all this so that you can see the entire Earth in one fell swoop. And so we see basically the storm systems that are passing our way from west to east. And there is a counterclockwise circulation system here near Alaska, well, near the Aleutian chain of islands. But I also like to point out the cyclonic motion, the clockwise motion of these storms here very close to Antarctica. And there's just a whole lot of them encircling Antarctica. You would not be wanting to circle the southern tip of South America or of Africa right now. Okay. In addition to the winds, we can look at the temperatures. And you can see that it's pretty symmetric. The temperatures are pretty symmetric, and that's because we're near the equinox, where the tilt of the Earth with respect to the sun is negligible. And so there's pretty much even heating from the equator upward. The irradiation gets less, and from the equator to southern latitudes, the irradiation gets less, or the angle of the sun gets lower and lower. And so everything gets cooler. Similarly up here. What's interesting to me also is just how much the temperature is. And if you were to take an average of this in April and compare it to the averages of previous years, you would find that the temperature has risen since pre-industrial times, 1880s or so. The temperature has risen about 1 degree Celsius on average, or about 1.8 degrees Fahrenheit on average. And a lot of that has to do with the amount of carbon dioxide, which is in our atmosphere, which has been getting pumped into our atmosphere by our industrial ways, transportation, energy generation, manufacturing, etc. And if you were to look in the Northeast, what's going on, you would find that we have 434 parts per million. And so that's pretty high compared to what it used to be in pre-industrial times, which was 280 parts per million. We now have an excess of 44% or so. That's a lot of an increase in carbon dioxide. Even in the tropics, in Brazil and in Africa, equatorial Africa, the levels are still in the 400s. Here is where most of the carbon dioxide is getting sucked out by trees and their photosynthetic ways, but it's not enough to compensate for the overall carbon dioxide in the Earth's atmosphere. Just saying. Okay. Let's see, what else do we want to do? I should also show the rain. And that would be, is it this? I believe this is the rain. No, this is the rain. So if you wanted to see what's going on in terms of the rain, you have a lot of stuff equatorially, which is not surprising. We have the prior weather system that passed by us, and we now have this other weather system passing by us. And of course, all these cyclonic systems have rain fronts associated with them as well, or perhaps they'd be snow systems. All right, so I think that's enough of the Earth Null School weather maps. Let's move on to what else is happening, and that would be the pandemic, which is located here. Okay. Johns Hopkins provides animated maps of both the cumulative cases over time, but I'm going to focus today on basically what's been happening day to day. And so you can follow the trend of coronavirus infections by country All right, so here we go. It starts in China in January, and then gets intense in China, and then gets a little less, but then it starts picking up in Iran, Italy, Europe, United States, Canada, Alaska, South America, Brazil, Australia, and now Africa, and Russia. And Russia is something to watch out for as time goes on. We're still in the midst of it, supposedly near the peak of infections. The hope is that they will go down soon and that we'll be able to figure out a way to open up our economy. It's going to be a heck of a challenge. All right, so that's the pandemic. And let's talk about earthquakes. Meanwhile, the Earth continues to do what it does. This is the IRIS system. They are monitoring earthquakes around the world, and you can find those which are occurring today or have occurred today. They're in red. And so you have one that was in Crete, near Greece, or part of Greece. That's Crete. And there's another one in the Aleutian, part of the Aleutian island chain of islands near Alaska. And there was one in western Idaho about the end of March, which got up to 6.8 on the Richter scale. So that's the biggest bruiser of note. You can see that if you look at the past 5 years, there's all these purple earthquake markings, and they delineate beautifully the ring of fire, the so-called ring of fire, which is associated with the edges of the tectonic plates, the crustal plates, which are jostling about. Some of them are going underneath others. Some of them are crashing into one another. Some of them are kind of riding along upwards with respect to the other. And that's where all the commotion occurs, producing earthquakes. All right. We also have volcanoes. And the red ones are the most recent. They've been occurring most recently, active eruptions. And we have ones in Italy, Stromboli and Mount Etna. They continue to be active. I don't think on a very violent level, but they're definitely erupting. And then there's a bunch of volcanoes here in Indonesia, which include Semeru and Krakatoa. Back in the early 1800s, Krakatoa blew big time. It shook the world. The explosive eruption was said to be heard around the world. And of course, it caused many, many deaths. So these volcanoes, you might notice, they also congregate around the borders between the tectonic plates, and they're often associated with earthquakes. And so the Earth continues to do its thing. It's an active planet. It has not completely cooled off. It's like other planets like Mars, which is pretty much tectonically dead. And of course, the moon is pretty much tectonically dead. So that is pretty much, I believe, the Earth. And so what I would like to do now is to start up a program. We're going to go look at the sky. Stellarium, I have it as a program, but you can also go to Stellarium and use it as a interactive web site. So I have it set up for pretty much today. I'm going to increase the field of view. We're looking south, and right now the sun is pretty high in the sky as I talk with you, but I'm going to change the date and time. to, and we want to, I have to remember how to slow things down, but we're going to increase the hours. And we're going to let it set. Let the sun set. And you might notice that the sun is setting not due west, but a little bit north of west. And that's because we are not exactly at the equinox, which occurred in March, but basically 1 month away. And so instead of setting due west, the sun would have risen due east and set due west. It now starts to set a little bit north of west. And that's because it's taking a much bigger arc across the sky, or a slightly bigger arc across the sky. I'm going to move this so that you can see the zenith that's looking straight up. And so we now have everything we need. We can now let the sunset take hold. And you can see familiar constellations setting in the west. I'm going to get me out of the way. There we go. And the Pleiades are setting. Venus can be seen in the evening sky. That's what the brightest object you will be able to see. You'll be saying goodbye to Orion with its lovely nebula, the Orion Nebula. This software program calls it the lost jewel of Orion. And I will be showing later the Rosette Nebula, a picture taken by one of our amateur astronomers in the Gloucester Area Astronomy Club. I will also be showing not all these lovely clusters, but faint galaxies, pictures of faint galaxies in this area to the left of Leo the Lion. This is the backwards question mark that you can see in the sky, making up Leo the Lion. It's its mane, and this is Leo's hind end. If you look in this direction in a dark sky, you'd be able to see the Beehive cluster naked eye, and it's pretty good in binoculars as well. But I'll be looking at galaxies here in the constellation of Coma Berenices and in Virgo later on. Okay, that's about all I want to show you towards the south. Let's start looking towards the north. With the zenith still available, that would be looking straight up. So here you're now looking towards the north, and you might be able to see that the Big Dipper, here's the Big Dipper, is pretty high in the sky, which is a good time to look at galaxies in this area of the sky, which I will look at. Many of you know that you can use the Big Dipper, which is part of Ursa Major, the Big Bear. You can use these pointer stars to point towards Polaris, or the North Star. This is the star that never moves. It's in the direction of the Earth's spin axis, and so everything else rotates around it. And right now, Ursa Majors is on the high part of its motion around the North Star. And I think that's about all I want to say here as well. It's an advantageous time to look at galaxies here. Okay, so that's it for looking at Stellarium. I'm going to get back to the PowerPoint, which is now a PDF. And so we have images of the moon, or a sketch of the moon, which is very nice. This was taken by, or done by Richard Lukey, a member of the Gloucester Area Astronomy Club, and it's a piece of the moon. Now, the moon is not in this phase right now. It's close to new moon, as I said, but this was sketched on March 29th when it was near first quarter phase, and that's a good time because the division between day side and night side is right in the middle of the moon, okay? And because of that, you can see a lot of detail along this day-night transition. It's called the terminator, including craters such as this one, Aristillus, and you can see one of the rims is being sunlit, and you can also see evidence of rays. That's due to splash ejecta from the impact of something hitting the moon way back when. He also notes Mare Imbrium. That would be one of those lava beds that seeped up non-violently, we think, and covered the moon back around 3 billion years ago. And then there's other moons, other craters, and you can see little smaller craters inside of craters, and even little mountains popping up inside of the craters. These are all due to impacts, we believe. And so we're seeing the moon as at a distance of 240,000 miles. That would be, we see the light reflected, the sunlight reflected from the moon as it was 1.3 seconds ago. So we see basically the moon at a distance of 1.3 light seconds. All right. Venus, it's farther away. Basically, the light reflecting off the cloud tops of Venus takes about 6 minutes to get to us. So we say that its distance is 6 light minutes away. This is an amazing image taken by Frank McMahon, also of the Gloucester Area Astronomy Club. And you can see that it has, let's see, maybe I can do this. Here, that's better. All right. Again, it's in first quarter. It has a first quarter phase, and that's because Venus is following the sun. It's about 40 degrees away from the setting sun, or the set sun. And so it's getting irradiated by the sun in this direction, okay? I've been told by Frank McMahon that this blue rim may be an artifact of the lenses that were involved in taking this image. But this is an amazingly good picture which he has made of Venus. All right. This imaging, and what I'm going to show you a video of Saturn as taken by the Cassini mission, is not done by NASA. This is not done by the Gloucester Area Astronomy Club, excuse me. It was done by NASA and the European Space Agency and the Jet Propulsion Laboratory. They put together this fabulous sequence of pictures, making it into a video of the Cassini spacecraft passing by and through the ring system. And so I'm just going to show it for you now, and I hope you like it. Wow, that's pretty awesome, for sure. Thank you, NASA, for doing this. Especially impressed with the rings. Like many planetary scientists are very impressed with the rings, how thin they are. You see them from above, and then boom, you're seeing them from below. The transition from above to below is razor thin transition, which suggests that the rings are very insubstantial. There isn't much to them, and they're very, very bright. And because of that, planetary scientists, they've been going back and forth on this, but they now think that these rings are short-lived. What we're seeing is relatively new stuff, perhaps wasn't around millions of years ago, and perhaps won't be around millions of years from now. It used to be a debate between them being short-lived and long-lived, but now they're opting for the idea of them being short-lived. Okay, so that's Cassini's fly-through of Saturn's ring system. Fabulous. Okay, we're going to move out from 1.3 light hours to Saturn to, we're going to go past some stars which are much, much closer to us, tens of light years, to hundreds of light years, like Betelgeuse, the red supergiant star that was seen to dim considerably over the past few months, but now has come back up to its more normal brightness. We thought that might be a harbinger, the dimming of maybe an explosive event coming, but it's beginning to look like it's just part of its strange variability. So in between Betelgeuse in Orion and Procyon in Canis Minor, there is this tiny cluster of stars called NGC 2244 and associated nebulosity. And you can see this courtesy of Barry Yomtov's really beautiful picture. And here it is. Here's the cluster of stars. We're seeing the hottest, youngest, most massive stars. These are the stars that don't last long. They're the Mozarts and the Jimi Hendrixes of the stellar world. And they are putting out an awful lot of ultraviolet light and winds. And it's the light which is powering this nebulosity. It's causing this gas to get its electrons ripped off of the hydrogen gas, mostly oxygen as well, and sulfur as well, but hydrogen mostly. The electrons get ripped off, and when they recombine onto their host protons, host nuclei, they emit light and characteristic colors. And for hydrogen, red is the most prominent of the colors, and that's why these nebulae often appear red. So that's from the light. The light and the winds do a lot of sculpting. You can see that there's this cavitation in the inner parts of this nebula, and that's because the light has worked on the gas, and the winds have pushed it away. And you can see erosive processes here with these so-called pillars. They're all pointing towards the star cluster, and they're kind of like the hoodoos in Bryce Canyon. They're particularly resistive concentrations of dusty matter, which are slowly getting photo-eroded away by the intense light from these stars. So what a fabulous picture, thanks to Barry Yomtov, the Gloucester Area Astronomy Club. So that was to the south, towards the south, or the equator, looking towards the south. And now we're going to be looking towards the north, towards the Big Dipper. And as you know, you can use these pointer stars to find the North Star, but you can also use these two stars to find this grouping of galaxies. It's shown here as a threesome, but M81 and M82 are the dominant two galaxies, and I'm going to show those next. And then I'm going to move on to show this galaxy, M101. All right. So these pictures, or this picture, this view of both galaxies is by Phil Urbains. And here is M81, a beautiful grand design spiral galaxy. And you can see that its inner parts are yellower than its outer parts, which are kind of bluish. And that's because the inner parts contain stars which are mellow yellow stars like the sun. Those are longer lived stars of lower temperature, and so they glow yellowish, reddish at their surfaces. By contrast, in the disk, you have bluer stars. Those stars are inherently younger because they just don't last as long. They're hotter, more luminous, more massive, and they just don't last nearly as long. And so when you see them, you're seeing evidence of recent star formation. By recent, I mean in the past 10 million to 100 million years, compared to these, which are billions and billions of years old, okay? And you might even see a peppering of those red nebulae in the disk of the galaxy. So this galaxy continues to form stars in the outer disk. By contrast, we have M82, which is probably a disk seen edge on. We don't really know. But there's something strange happening to it. You can see red nebulosity above and below this disk seen possibly edge on. And so I'm going to blow this up so that you can see this outflow of fluorescing gas, especially hydrogen. That's what we're seeing. And this is evidence of a huge galactic wind. And that wind is the result of a tremendous episode of star formation, what we call a starburst, which has happened in the last several million years. And the star formation has led to lots of massive stars, massive luminous stars, hot stars, which are fluorescing this gas, okay? Ionizing and fluorescing the gas, making it glow. But what got it out there is probably a sequence of supernova explosions. Massive stars fervently live over just a few million years, and then they violently die in the form of supernova explosions. And it's the wind, the collective wind from these supernova explosions, which has probably lofted all this gas beyond the plane of the galaxy. And now that gas is being irradiated by the remnant hot stars in the nucleus of this galaxy, or near the nucleus of this galaxy. And so this is a very interesting starburst system. It's the nearest nuclear starburst in a starburst galaxy to us. It's the nearest one. And I can't remember its distance, but we'll find out soon enough. 12 million light years. Okay, so we're seeing those galaxies as they were 12 million years ago. The same picture, M101, it's off the handle of the Big Dipper, okay? If you saw it through a good size amateur telescope, you would just see it as a haze with some structure, perhaps. If you have relatively good eyes, you'd be able to see some of the spiral structure. But through long exposure digital images, as this one taken by Phil Urbains, you see beautiful, beautiful structure and color. And so here we have a vast spiral galaxy seen face on, lots of blue light from hot young stars in the disk. So star formation is going on throughout this disk, even as we speak. This is all the recent stars that have been born within the last 100 million years. And if you focus on the red regions, the red emission nebulae, those are regions where stars have been forming intensely for the past 10 million years or so. These, at this distance, which I can't remember what it is, we'll find out soon enough, it's around 20 million years or so. At this distance, these objects are huge. They're about 1,000 light years in size, each one of these, and they're complexes, starburst complexes within the disk of this galaxy. If you took one of these out and made it its own galaxy, it would be its own starburst galaxy. Perhaps not as big as M82, but it would hold its own as a barn-burning starburst system. You can also see in this beautiful photograph these darker dust lanes of lanes of obscuring dust. And those are tracing where stars are forming now, okay? It's going on inside clouds, dusty clouds of molecular gas, cold molecular gas. So much of the action is hidden from view inside, but then they will bust out and start forming nebulae like these over the next few million years. So great galaxy. This one is bigger than the Milky Way galaxy. It's several 100,000 light years in size. Another final thing that I like to point out is that the spiral windings aren't all spiral. They have some crooked arms. Here's a crooked arm here and a crooked arm here. And this can be seen at other wavelengths, like in the ultraviolet. And this sort of structure might be due to gravitational resonances or tidal resonances within the galaxy itself and between the galaxy and other small galaxies that are basically in the orbital thrall of this galaxy, this giant galaxy. Okay, thank you, M101. Thank you, Phil Urbains. 21 million light years. Okay, I was pretty close. Now we're going to be looking south again. Here's the back end of Leo, and there's a whole bunch of galaxies that can be seen around here in Coma Berenices and then down into Virgo. But I'm going to pick on right now NGC 4565, which is near the limits of good imaging with amateur telescopes, around 60 million light years. So we're seeing this galaxy as it was 60 million years ago. And there's a great image by Mario Mata. And by the way, all these images are in the Gloucester Area Astronomy Club's gallery of images. They're all available to you and just about anybody else with an internet connection. And you can see this is an edge-on galaxy. We're seeing the galaxy as it was edge-on. So take M81 or M81 and M101, take them and tilt them until their disk is seen edge-on, and that's probably what you would see with NGC 4565. You would see a central bulge of relatively older stars, and then you have the dusty disk, and it's in the dusty clouds of molecular gas where new stars are forming. Now, through a decent-sized amateur telescope, you would be able to see this. You'd be able to see that it's very elongated. It's called the needle galaxy because of the elongation. And so it makes it a very unusual object to see through a telescope, near the limits of visual discernment. Okay. It is galaxy season. Whenever Virgo is up in the sky at night, that's where there's a whole bunch of galaxies between Virgo and Coma Berenices, which is the hair of Berenice. And there, what we're looking at is a whole cluster of galaxies. It's called the Virgo cluster of galaxies. It contains about 1,300 good-sized galaxies. Those are the ones that we can see. And there is this small system within the Virgo cluster called Markarian's chain. And it's highlighted here. It's a good target for people with amateur-sized telescopes, because that chain fills the field of view. You can see the whole series of galaxies, sequence of galaxies, in one field of view through the eyepiece or with an imager. And that's what Barry Yomtov has done. And he took this lovely picture of the chain, and you can see that the chain consists of all kinds of galaxies. Here we have a spiral galaxy. This is a barred spiral galaxy. And then we have these monsters here, M84 and M86. Those are giant elliptical galaxies. And those are probably galaxies that have cannibalized other galaxies. Any galaxy that got too close, they've eaten them up and become these giant elliptical galaxies. And so this is just a great sequence of galaxies that amateur astronomers love hunting and pecking for these sorts of systems. So that brings us to the end of this presentation. I want to thank Zoom, obviously, for providing this platform, digital platform, online platform, Rockport Public Schools and their weather station, University of Wisconsin, and NOAA, which has the weather satellites, the Earth Null School, which models all sorts of atmospheric processes, Johns Hopkins University for its animated maps of the pandemic, the coronavirus pandemic that is wreaking havoc right now. Incorporated Research Institutions for Seismology, or IRIS. That's the organization that provides the earthquake maps, the updated earthquake maps, volcano discovery for the volcanoes, Stellarium astronomy software for the views of the night sky, and NASA Jet Propulsion Lab, Space Science Institute, European Space Agency, and the Astronomy Picture of the Day, which all have helped to bring this fabulous fly-through of Saturn's ring system to us. And lastly, members of the Gloucester Area Astronomy Club, including Phil Urbanes, who took this image of the inner parts of Markarian's chain of galaxies, which is part of the Virgo cluster of galaxies, which is part of the Virgo supercluster of galaxies, of which we are a part, the Milky Way. And there's M84 and M86. And then these interesting galaxies, the eyes, which show very close and intimate interactions between two galaxies. So on that note, I want to stop sharing the screen. And thank you for hanging on all this time. I want to wish you all very well during these disturbing times. And I hope to see you again. Bye.